Good afternoon, everyone. Thanks for giving this opportunity to speak at HPSF conference and showcase the work what we are doing at C-DAC under the NSM Supercomputing Mission. Okay. So I will be briefly telling about the story of how Spack has how Spack has impacted us for the NSM Supercomputing Mission and the machines deployed under those missions. So basically, how the revolution of Spack initially, we started using Spack in late 2017 or 2018, and we were following the updates, regular updates with the Spack, and sometimes whenever we required, we are getting back to Toad for the anything which we need as an functionality or as an any issues there. So overall, if you look at earlier we were using modules as an to make it available for the users, and now we are completely moved from modules to using a Spack only. So again, under the National Supercomputing Mission, this is the mission hosted by the Ministry of Electronics and IT and the Department of Science and Technology, Government of India. And the C-DAC is one partner of this NSM mission, where we are taking care of deploying the machines across the country and handling the user base to support the user base, their request and all. So about the C-DAC, a brief introduction. C-DAC has been formed in 1988, and we are now our presence is at 12 different locations across the country. And we are in the HPC domain, we are in health informatics, we are in cyber security, multi-level computing, education and trainings and all. So our department basically takes care of HPC and quantum computing as well recently. So as an C-DAC person, I'm basically taking care of deploying the application on NSM supercomputers. So this is the brief introduction, like how National Supercomputing Mission has grown its computing capabilities. So we are having 34 systems with a combined compute capability of 35 petaflops, and in near future we are coming up with the almost 40 petaflop machines in next few months. And we are having a huge user base as an NSM users there. We are having almost 7,000 users from 200 institutions. The number of jobs executed on those systems crosses the 10 millions over there. So we have like 7,000 HPC users across the 200 institutes. Those institutes include the research, core research institutes, and the academics as well. We could see the number of jobs executed on those systems. We have like 1,700 plus PhD students who are actively using those systems for their research work, and some publications numbers like 1,500 plus publications were there. Also, as a part of NSM, we are having 4 verticals there. One vertical deals with the research and development. One vertical deals with the trainings and all. So we need to train the manpower as well to use the systems efficiently. So we across the country, we have trained almost 22,000 plus skilled manpower there. So these are the machines deployed over the time, number of machines deployed. Recently, we deployed IIT at the IIT Madras location. Last month only we released it for the user. Our machines again is a mix of everything. CPU, GPU is in CPU as well. We started with Skylake. We're having AMD. We're having ARM as well. ARM, Fujitsu ARM, and also we are having the recently Sapphire Rapids as systems as well. And one more thing, this system, as I told, we are having the different mix of architectures with respect to CPU and GPUs as well. We have GPUs, AMD GPUs, NVIDIA GPUs, and Intel GPUs as well. And from CPU point of view, we're having AMD, Intel, and ARM as well. So it's very complex to support all the users working onto these systems. So migrating one user from one system to another system is a big challenge there. And thanks to Spack community, or Spack basically, to take care of these challenges very efficiently. So these are the software stacks. Basically, we are using this software stack, or we are deploying this stack as an application stack when we are releasing it to users. And we are also having a ticketing portal where ticket, like user, whatever request, whatever extra things he wants, he can raise the ticket, and our team basically take care of resolving those tickets. So and the quality of ticket and quantity of tickets also varies there. So quality in the sense, some of the users, new users, they ask very new questions or very basic questions, whereas some of the expert users, they may ask for, let's say, my compute time should not, like, I'm getting this XYZ performance on this system, and with some mathematical modeling, I should not exceed the performance or the limitation, or I should not cross the, let's say, XYZ plus delta time there. So we need to minimize the delta. So there are variety of users who are the expert users as well, who knows what is going inside like each compute unit and how much they're expecting to get the performance out of the different systems, and they raise the ticket to get in case they are not getting the required performance there. So handling those type of tickets is very critical for us as well. And for the basic users, we are having the we can handle it very easily. But sometimes again, if PhD any researcher is working and he is not ready to share any codes with as an application person with us, then it's very difficult challenge for us as well, because without sharing the code, how we can compile or how we can give the support to that user, that is a big challenge there. And again, from their perspective or researcher perspective, it's very genuine concern as well. If they are doing some research or if they are writing their PhD thesis, they don't want to share their code, but they want to use the system effectively, and the performance, whatever they are expecting, they should get it. So these are the different domains or the applications which we are deploying there. Again, we are, as an application monitoring system, we are having a Chakshu as well. So let's say if job monitoring portal is there, so to monitor the effective utilization of CPU, GPUs, and all. So in case user is consuming resources, that's fine. But it's just holding the resources and it's not utilizing the resources, then we are sending some alarms to those users that your job is not getting, it's not utilizing the proper resources there, so you please take care of it. So sometimes we identify main bottleneck or main thing is, as a scientist, they don't care about number of tasks they are trying to spawn or number of nodes they are trying to use. They just, irrespective of syntactical changes and all, basically there is a gap in the understanding of the HPC systems. They prefer or they expect that by just tuning or by just changing the MPI ranks, their job should work effectively, but that's not the case. So we identified those bottlenecks there, and then we again started to train the user base through regular boot camps and workshops there. So every NSM system, we are quarterly once, we are taking sometimes online workshops, sometimes offline as well. As an indigenous development, we developed our hardware team has developed Rudra motherboard. So our recent systems is based on the Rudra system, motherboard system with the Cascade Lake and the Sapphire Rapids. And we do have Trinitra interconnect for indigenous developed interconnect. We also developed the ARM processor, and we are working on RISC-V as well. Some of our teams has started working to explore the possibility of using RISC-V for HPC workloads kind of thing. Again, these are some of the applications which are normally we are porting or we are making it available. Most of the users, like depending upon the type of institute, if the institute is working on CFD code mostly, so we are making sure that the CFD codes or whatever CFD applications are there, those are well optimized for their use. And for like other applications, let's say any plasma research institutes are there, they are working closely with any molecular dynamics code. So we segregate and we give we try to give them the optimized version of those applications. Some of the visualization programming models and all. We also give, like we are also using a container technology like as an uptainer or an in-root. So these are the traditional challenges before coming to Spack. How we like everyone sitting here, I guess, has gone through the same cycle. How we can port the application to HPC system, how we make sure that we are getting the good performance there or the expected performance, how we are making sure that the ticket resolution time. Let's say user has raised the ticket and it should be get resolved or user should get the proper response time there. So with the Spack, we identified we were having some of the statistics as well, but I couldn't put it here. But we observed that when we started using Spack, the total ticket resolution time has gone very significantly down, and the user response time as well gone very significantly down. So earlier we were using modules. So we gradually started using Spack in 2017, where I personally used Spack just to identify the dependency list of the application, because it was very critical to understand the dependency as well for an application. And then gradually, sometimes in initial days, I used to compile the application with the Spack and then create the module files for those binaries there. And then gradually moves to from module files to Spack now. So now current systems are completely Spack based. So as I told you, like the humongous amount of the tickets getting raised, and the workload or the resources what we are having with us is with the limited resources, we need to resolve those issues. So earlier, for each site, we used to deploy 2 person as an application guy is there, who used to take care of all the tickets there. But now with all 15 sites, hardly 3 or 4 persons can take care of handling all the tickets. So that is only achieved with the use of Spack there. So I may skip this slide because everyone knows about this Spack, what is Spack, and these are the challenges what I mentioned earlier. So one biggest challenge what we observed initially in late 17 or 18, that the performance of some applications were not up to the mark what we are getting with the modules. And then our institute head and all, they ask us to do the thorough testing of the application. If we are getting the performance with this Spack, then we will go ahead with this Spack, otherwise we will continue our modules and all. So we compared some of the application performance there, like OpenFOAM, GROMACS, WRF, NAMD, and LAMPS. We observed that for 4 applications we were getting good results, like comparable results, but for GROMACS, maybe at that time the GROMACS recipe in the Spack was not mature enough. So we were not getting the good performance of this GROMACS install Spack at that time. But then gradually, as we move on, we are getting the comparable performance, and then once we shifted to Spack, now there is no concern of performance at all. Initially, as every users were trained for using modules, module load command and all, and now like they were not happy with the hashes what Spack generates basically, or the long list of module file names were there. So they were very, it was very, very challenging task to tell that user that hashes, why those hashes is required to in the module file namings, and why there is a need for those many like OPT and the compiler name, your application binaries lies there, right? So it was kind of challenging over there. But now again, yeah. So we compared the, as I told, GROMACS and OpenFOAM, WRF LAMPS. GROMACS case study we could improve at a later point of time. These are the key points. Installation time got significantly reduced, and we are getting the good, very good ticket resolution time. Optimize the performance, the whatever RFA applications we were using earlier. So now we are getting the optimal performance. Like performance constraint is not there now anymore. With like scalability, multi-version support, that is well taken care of by Spack. Earlier scenario, that is time consuming, and then admin overheads were there, and error prone. Error prone in the sense that manual, like when we are doing any manual compilation, it's very obvious that we will end up with making some errors there. Now with the automation like Spack, and we are making sure, like we are happy that we are not getting those many errors at runtime. So these are the snippet of the tickets raised on each side, number of tickets raised, and their quality of tickets as well. So so earlier we used to have like weeks of ticket time, that once any researchers raised any ticket, he may get the final outcome within maybe 2 or 3 weeks. Now the same task we can do it within a day or two, and we are not constrained, or we are not bothered now with the diverse set of applications. Like any set of application which is available in Spack, it's very easy to user as well to install it by them as well with the upstreaming of the Spack. We do have some of the custom codes, like as I told earlier, that some of the PhD guys, they are not researchers, they are not willing to share their code. So, and they wanted Spack to be used for their application build as well. So without sharing their code, it was very challenging task for us, that we asked them the dependency list, and then we asked them for the any kind of any constraint with respect to any dependency versions and all, and so that we can create the recipe without seeing any code there. And then we made it available, that Spack recipe inside their home directory, and then we asked them to run this Spack commands. If it succeeds, then they are using it. Otherwise, kind of it's a cyclic thing. We need to multiple times iterate over the same recipe and for bug fixing and all, and then we give it to users. So some of the code which they were using, like line beats and all, those codes were there, and even it's our observation that even the code what they are using, or any researchers is using, it's a kind of their ancestors were using it, and they are following the same thing, same pattern. They are not modifying the build system. They are not modifying anything unless we force them to use with recent updates with respect to Spack, with respect to CMake, or whatever else. And recently, we integrated Spack with reframe as well, so that we can regularly check up with the performance deviations as well, in case it happens. And we are using a reframe and a build test to make the acceptance test. Before giving the system to end user, we are making sure that acceptance tests were met, and we are using reframe and the build test there to make it happen. This is a big challenge to our HPC users, to make them Spack aware, because they were very tuned for the earlier systems or earlier ecosystem, and it was like we initiated this training modules, or training them to use Spack and forcing them to use Spack, just because it gives us flexibility and like number of application what we can deploy with the Spack and all. That is we can that is unlimited, or most of the application we can do easily with this Spack. So regularly we are taking the boot camps on each NSM site. We are having the training programs to train the user for Spack, building the Spack aware community. So these are the same thing. So before Spack and after Spack, what are the impacts basically? So the performance inconsistency or uniformity is there. And with the Spack, now we are consistent with the applications. Because again, one more challenge with us lies where the manpower we were recruiting, they were not with us for a long period of time. So it was very challenging for once they learn something basic, and then they move on to some other challenges. And in that gap, whatever learnings they were having, they were carrying it with them, and somehow the way manual guy, like that guy was doing the manual installation, and the next guy how he's taking handover, the gap, we identified most of the gaps there, and those gaps made us our users suffer a lot. So now with this Spack, I think that gap is not there. So any person is coming as a new joinee to us, we will just train him to use the Spack, and now he is capable of using the Spack simply. So as an acknowledgement, I will acknowledge our institute, C-DAC, and NSM National Supercomputing Mission, and HPC Tech team in specifically. Thank you.
All right, thank you so much. I think that Jose should come start setting up, but in the meantime, does anyone have any questions?
So you mentioned you're doing training for your users. Are you using our tutorial for that, or do you have your own in-house tutorial, or how are you doing the training?
We are having the basic. We are not using any tutorials till now. Okay. Yeah, like our basic things, basically how to use Spack and how we can install the Spack. Those things are there. Yeah.
Thank you. I think we have to move on, but thank you again. Round of applause.
Thank you.